So good evening. I'm Glenn Newell. I run the astrophotography program for the San Jose Astronomical Association. So what we're going to do tonight is I'm going to talk for a little over an hour while we're waiting for it to be dark enough to see Polaris, because we need to get our cameras and telescopes pointed to true north so that we can track the apparent rotation of the stars. So it makes a good time for us to do these kind of lectures, and then I'll turn my car off and then I'll demonstrate deep space photography with this rig here. And there's other club members that you know, if you respectfully ask them questions, may be able to interested in helping with answers as well, and I'll certainly be here to answer questions. So let me get started. So there's a couple slides here about the club itself, and then we'll get into the topic of various types of nighttime photography. I have very helpfully put QR codes on these slides. I was about halfway through before I remembered that there's no internet out here. There's no cell coverage out here, but maybe if you take a picture, you can still use it later or something. I actually don't know, but it works later. Okay, good. All right, so that's easier than, you know, typing in the URL or whatever. So so we have two ways that we communicate with the public. We have the SJAA.net website on the left, and then all of our public outreach programs are available on Meetup, and they're all free for you to attend. There is one star party that we do called Starry Nights. We do it every month just down the road here at Rancho Canada de Oro. That's done in conjunction with the Open Space Preserve, and they need to control the amount of cars that show up. So for that particular event, you have to register on Eventbrite, because that's the platform they have chosen to get a ticket, but it's still free, and that's a really good thing to go do. There's, you know, a whole line of visual observers with scopes that you can walk down and look through them all at different objects and stuff. So yeah, we're a super active club. So we do parties in San Jose. We do this one I mentioned at Rancho Canada de Oro, star parties. We have this imaging program. We have a binocular program. We go down to Pinnacles, which is 2 hours from here, but even darker than this location. So there's lots of things we do, school star parties. So we're a pretty hyperactive club. There's usually about 300-400 members that have joined the club. It's $20 a year. And then there's like 1,500 people that have joined the Meetup group, where we post all these activities. Okay, so again, some of the programs, we have classes. If you think you want to get a telescope, it's a good idea to go take this class, and you can borrow a telescope and make sure you're really into it or not, or maybe what type of telescope you want before you go and spend money and get sold maybe something that doesn't fit your needs. So that's good. And you know, we have swap meets, and we do solar observing on one Sunday a month. We have a place where you can bring your telescope if you have problems to get it fixed. So lots of programs. So that was the commercial part. Only $20 a year, folks. So, and there are for members, there are other events that are not open to the public, where they go and do either visual imaging or visual observing or imaging, and it's just the club members. Okay, so the rest of this talk is about various different types of things you can do with the camera at night, going all the way from a camera out on tripod to a deep space astrophotography rig like this here. And actually that picture in the upper right is a picture of one of those Rancho Canada de Oro star parties And you can see all the row of telescopes there along the edge of the parking lot that people are using. Short story, this image on the left here is my first successful astrophotography image. So that's the Lagoon Nebula. I took that with a DSLR and a $90. No, I think I had my 8-inch RC by that time, I think. Yeah. So I was pretty happy with that. But so that's a big bright nebula. It's an easy first target, and that's what it came out like. And this is probably the image that I'm most proud of so far. So a year or two later, and this is actually a mosaic. It's 3 frames merged together, and it's made up of about 250 different individual exposures. So it's red, green, blue, and luminance times 3 times however many, to make about 250. And I actually gathered this with the robotic telescope from Australia. That's another thing you can do versus, setting up your own gear. If it's cloudy or whatever, you can go online and rent telescopes by the hour to take images. So this is the, I can use my whiz-bang thing here. So this is the M42, that's the Great Orion Nebula. This is M43, the Running Man Nebula. This is the Horsehead Nebula. Very difficult thing to see visually. It's because it's a dark nebula. It's very dim. And this is the Flame Nebula. And if you're familiar with the constellation of Orion, and you know that at least in Western culture, right, Orion has a belt and it's got 3 stars in it, right? People know that? So this is the leftmost star and the middle star right there in the constellation of Orion. So if you look at Orion with your naked eye and you look below his belt, there's this little sparkly area, which people call his dagger or his knife. You can actually see this with your naked eye, a little sparkle there. Okay, so that's just my first picture and one of the ones that I'm most proud of, just to show you what's possible. Okay, so we're going to talk about lots of different types of nighttime photography or astrophotography, and then there's some things that this lecture is getting onwards to almost 2 hours, so there's still a lot of stuff that's not in here, so I'll tell you what's not in here yet, right? So we'll talk about nightscapes, which is, camera on a tripod. We'll talk about star trails, talk about time-lapse, wide field, planetary, briefly, and deep space is my passion, so we'll get to that. And so things that aren't in this lecture yet, obviously you can do solar photography during the day, and there's different flavors of that. And then there's a kind of a newish hobby, which is electronically assisted astronomy. So you're still kind of doing visual, where you don't have a lot of computers and a lot of cables and wires, but you put a video camera in the eyepiece and then look at a screen, and that gives you a light amplification to where you can see more than your eye could see. Okay, then there's a whole nother category of stuff that's not in the lecture that you might find interesting, is the whole area of amateur science or citizen science. And there's things that you can do just for your own interest. Photometry, astrometry, that thing, spectroscopy, or you can actually, there's scientists that want your data, or they want your eyeballs, because they're going to give you on the web, a whole list of images, and they're going to ask you to look at them and see if anything's moving in the two, and that's how they can detect an asteroid or a comet. So there's lots of different ways for kids or adults to get involved with this hobby and through citizen science. A really good site if you're interested in the deep space, is astrobin.com. It's kind of like the Facebook for astroimagers, and there's some social component to it in that you can like photos and whatnot. But the point is that people post not only their images, but they also post how they got it. So they post, I used this telescope with this camera, with these filters, with this mount, and I was at this location, and and I took this many red and this many blue and all of that. So that if you're trying to figure out what's possible with a particular kind of gear, you can search for that. What can I do with a 10-inch RC? Or what do pictures of the Andromeda galaxy look like, right? You can ask those kind of questions in the search engine, and it'll bring up all this amateur stuff that you can click on. I think the QR code takes you right to my page, which is there, and of course there's thousands of people that are posting their stuff there. Okay. So just a camera and a tripod. Here's some examples of stuff that I've done. The Milky Way, basically, people do where they paint the foreground with a flashlight or something. There was a gentleman from the club that did a really nice one. He just had his camera pointed this way, and he just walked over there to where the house used to be, and he just painted the chimney with a red flashlight, and it just came out really, really nice. So there's some examples of different things there. And here's a Milky Way bow shot. This is done by somebody, a club member, and he's been nice enough to blog about his journey in astrophotography, so he'll tell you how he got this shot and his other trials and tribulations in astrophotography. So this is the easiest place to start. It's the most accessible. A camera and a tripod basically is all you need. You do have to keep in mind that at night, if the temperature reaches the dew point, then you're going to start having moisture condensing on your lens. Is somebody trying to come in and they think it's locked, or no? Okay. Okay. So that's one thing that, as we go through the different types, then I'll start giving you tips as to how to address some of these issues. Your exposure time here, if you don't want star trails, is going to be limited by something called the Rule of 500, and we'll go into that in some detail. And of course, the how much gain your camera can provide, in other words, how high the ISO number it can go, will control what you can and can't do at night. And also there's the issue of more gain means more noise, so we have to have ways to deal with that as well. So here's a star trails example. So this is Mark again. I think this might be in his backyard, but this is one example. If you point directly at north, then everything is going to appear to rotate around you. And he built this up from a series of 30-second exposures. Whoops, sorry. And stacked them in Photoshop. So that's one approach for doing that. Okay, and I think I have to click on this. So then the next thing we want to talk about is time lapse. So it takes a minute for this particular one to get to the nighttime, but there's a lot of fascinating things that you can do with time lapse. So the sky will move overhead, and then you can add to it by having a motorized that either rotates your camera or slides your camera along, so that the foreground is moving as well as the sky. There's also that light painting that I talked about, where you could place lights to light up your foreground material, like a tree or some rocks or something, or you could paint them with a flashlight, different colors. So there's lots of different things that you can do with time lapse. This has some of the same challenges that basically all the different things have, which is how are you going to achieve focus, and then do control. We mentioned as a problem, so we'll talk about all of those. And there's also something about aperture flicker. So your DSLR is the aperture is wide open when you're looking through it, and then when you go to take the picture, it stops down to whatever your f-stop is, and then you stop and it opens back up again. So it turns out that it doesn't go to the exactly the same diameter every single time. So if you're making a movie out of this shutter going like this, you can actually get some flicker. So one of the tricks to time lapse is how to deal with that, and you can either deal with it in software, or some people will unlock their lens and move it just enough to where the electronics are disconnected, but not so much that it falls out of the bayonet. So use that one at your own risk. But that's a trick to freeze the lens in a certain aperture. And this tethered shooting here refers to being connected to a laptop. So you can have control over everything on your camera, but from a laptop screen rather than going through menus or whatever on the camera. And it also functions as an intervalometer. In other words, it's going to you tell it, I want 6 hours of 30-second exposures or whatever, and it's going to manage all of that for you. You'll need either an intervalometer or tethered shooting, usually to go beyond 30 seconds in most modern DSLRs, 30-second exposures. And people always ask about mirrorless cameras. Mirrorless cameras are great. Sometimes they outperform DSLRs. The problem is the manufacturers have made a decision to position these mirrorless cameras in the market in a certain place, and they have not released any software to allow them to be controlled in the way that a DSLR can be controlled. So you just won't. You could go buy a Sony A7 and it's an amazing, or the newer ones, it's an amazing nighttime camera, but you cannot use it with a laptop and control it because they just don't allow that, whereas their DSLRs can do that. Okay, let's see if I can move on here. So the next area would be, so before we had a camera on a tripod, now we want to start tracking the sky. We want to move with the stars. That allows us to take longer exposures, and so the easiest way to do that before you go to a full telescope mount like this over here is to buy a star tracker. So they come in different flavors. They're called, depending on who makes it, they're called Polaris or Sky Tracker. There's different models, but basically it's a little battery powered device that sits on your tripod, and it's going to move in the right ascension direction at the speed of the Earth's rotation. So the stars, it will track the stars. A few things you need to know. You need to know, how much camera and lens am I going to put on this thing, so that you buy one that can handle the weight. And usually they're demanding a 3/8 inch tripod head versus a 1/4 inch. So it's more the professional. So you might need to think about that. And then they need a ball head of some type. They usually don't come with one, and you'll see on that top picture there, there's a ball head between this device and the DSLR. So that's so you can point your camera wherever you need to, and then the whole thing will just move with the stars. So they don't provide that, so you have to buy that as well. And then they're all going to have some means of polar alignment. So they'll have, this is showing, this piece right here is a polar scope. This one is not pictured here, but there's a hole in the thing where you can slide a polar scope in there. And this is how you get aligned with true north, so that it's going to rotate, that axis it's going to rotate around is going to be around true north. And there's apps that will help you with that process. So this is one called Polar Alignment Pro, or PS Polar Align Pro, I think it is, yeah. And they'll present to you a reticle that's identical to what you see when you look through the polar scope of your device. And basically, if you look here where that orange dot is, it's telling you, okay, for your location and for this time, that's where Polaris should be in the reticle that you're looking through. So if you put Polaris right there, then you're going to be pointed towards true north. So that's polar alignment. And they also, these things can also use the camera on your phone so that you could put the whole thing up against the polar scope and see, and do it that way if you have a holder for your phone or something. Okay. So the next sort of step up would be a longer lens, right? At a certain point, that sky tracker is not got enough weight or enough accuracy for zooming in more. So in astrophotography we'd call this wide field, but yet it's it's much narrower than everything we've talked about to date, right? So it's probably 135 millimeters and up would be wide field. And so one thing people do in this case is they go ahead and use a telescope mount that they may have for their telescope, but they use a photography lens, either with a DSLR or in this case here you can see the similar or the same astrophotography camera I have on the telescope adapted to, this is a Canon 200 millimeter L prime lens. There's a Samyang 135 f2 that's super popular. So lenses in that kind of range are good for this. This is one particular, there's lots of wide field targets all around the Milky Way, right, as you go around. So this is the North American nebula here that's sort of shaped like North America, and for some reason I haven't figured out yet, they call this the Pelican Nebula. So that's one that I did. Okay. Then there's Planetary. So this is interesting because it takes a completely different approach than other types of deep space astrophotography. So planets are very small, so you need a high magnification, and fortunately they're also very, very bright compared to other things that we are trying to take pictures of at night, so that you can afford the high magnification. And it's almost helpful to have a really high f-stop, focal ratio, right? So for instance, I'm going to point the wrong way. Where's Lick? Lick Observatory. The nickel telescope there is a Cassegrain telescope, so you can set it up in different ways. You can put the camera up at the secondary position at the top of the telescope. You can put the camera at the bottom, or they have a place down in the basement and they can shoot the light down a hallway down in the basement, and it's f39 at that point, and that's what they use for Planetary, f39, because it actually helps with the Planetary. The other thing that's different about Planetary is we're doing what's called lucky imaging. So You know, when you look at the moon, there's this roiling in and out of focus, you know, if you're zoomed in, right? And that's the atmosphere that here on Earth that we're looking through, and that's called the seeing. And it's better on some mountaintops with, you know, laminar flow coming up from the ocean or something, and that's why observatories are in particular places they are, not just because it's high, but because the flow of air is smooth and not disturbed. But given that there is that seeing, unless we're up in space, the Hubble, we have to deal with that. So the way that we do that with Planetary is we take a whole bunch of really short exposures. Essentially, we take video of planets, and then we have software that goes through and figures out what parts are in focus and goes through a process of stacking this together, putting all the in-focus frames together to build up a detailed image. So the reason I bring this up, so the camera, the way you configure your telescope is different for Planetary than for other deep space. Other deep space, we're taking long exposures. We're usually using focal reduction. Planetary is the exact opposite. We're using like a magnifying lens, like a Barlow, between the telescope and the camera, and then we're doing this video, taking as short as possible exposures as we can at high magnification. So that's the difference. Okay. So now we come to deep sky. So it is the most expensive, it is the most complex, it is the most mechanically sensitive, and there's lots of places that stuff can go wrong. You know, I think I have 6-7 different pieces of software that are all working together, you know, to do this imaging here we'll do later tonight. So yeah, the Planetary and the mount driver, something to do autofocus, something to do image capture, something to do something called plate solving, which I'll explain, auto guiding, and then, you know, there's software to automate, sit on top of all that and automate it so that I can go in and go to bed and my telescope will just go do what I want it to do, right? So for some people here in Silicon Valley, it's kind of like the perfect storm of software and hardware, and that's where a lot of people get hooked into. But there's also kind of as soon as you start working on your image after you've acquired the data, there's a certain art to it, and it because it stops being science and starts being an art, working with, you know, Photoshop or something PixInsight or something where you're making artistic decisions versus, you know, scientific decisions. These are a couple deep sky images I've taken. These were both with that telescope on the lower right there, which is again a robotic telescope. You know, people don't realize all the things that are up in the sky. Isn't it spooky how I'm pressing the wrong button? How much this looks like a human eye? Isn't that crazy? And there's other people that have better shots than that, but there's lots of, you know, shapes up there that are pretty amazing. That's the Helix Nebula, and this is a galaxy in the southern hemisphere, Centaurus A. Okay, so let's talk about lenses for a minute, going back to the DSLR.
If I could interrupt them?
Yeah.
There's a Mercedes down near the gate and the lights are on.
Mercedes down near the gate with the lights on. Okay. So modern zoom lenses are great for terrestrial, and they've put, you know, daytime photography. They put a lot of effort into the engineering of those, and you know, for sports or whatever, they're good quality lenses. They have a lot of features that just get in the way when you're trying to use them at night. You know, you don't want autofocus, you don't want the ultrasonic motion. All that stuff just gets in the way. In fact, you might have better results with old manual lenses. So you can buy used, what are called prime lenses, a single focal length lens, and you might have sharper stars than you would using a modern zoom lens, and you don't have to, you know, turn all that stuff off that's just going to get in your way. So you know, I bought a lot of used lenses from. These are some of the places you can shop for used lenses. And again, this is where you know, like AstroBin, or there's a forum based for astronomy called Cloudy Nights. You know, if you have a question about a lens, how good it works for stars, pinpoint stars, then you can, you know, use those resources. Give you an idea of, you know, what you're going to see depending on whether you have a full frame or a crop sensor with the different focal length lenses. And on the right here, I've gone and taken this all the way out into the deep space realm. So if you remember that first or second image I showed you with the Orion, Great Orion Nebula, that's right there with the Running Man. And then over here we have the horse head and the flame. So, you know, with 1,000 millimeters, you're going to be just on the two nebulas there together, you know, and then it goes out from there. Okay. So I said over and over again that focusing was a challenge. So I'll give you two different techniques on that. So first thing you need to do is find a bright star or Jupiter, you know, a bright planet. And use your LCD display. Don't try to look through the viewfinder. So use your LCD display and use the zoom on it. So you can zoom in, and then some people even carry the little plastic magnifiers to even zoom in on that even more. And then you know, once you get that star to its smallest, tightest looking position, you know, you don't want to then bump your lens, so you can use something like painter's tape or something that's not going to gum up the lens to fix that. Or some lenses, if you take them out of autofocus, it'll lock the lens, or they have a focus lock switch on them. There's also you know, if you shoot tethered, there's a couple programs I recommend: Backyard EOS, Backyard Nikon. They have focus aid tools in software where they'll put your camera in live view and bring up a display of what your camera's doing and give you a number that's telling you the quality of your focus. Okay, and then we come to batten-off masks, and we use these as one of the techniques to focus telescopes. There's a particular one here that I'll recommend for DSLRs in a minute here, and I'll show you how the batten-off masks work. But this is actually a good representation right here, and I never have enough fingers for this, but so it's a diffraction grating, right? A diffraction pattern. So it makes stars have these diffraction spikes on them, and so it makes an X. And then there's a third line, and when it's in the middle of the other two, it's in the middle of the X, that's when you're in focus. If it's off to one side or the other, you're out of focus in one direction or the other. And if you're too far out, then it's just a fuzzy mess. But that's a great aid to get in focus at night. So I've tried, these sort of 3D printed kind of ones, and that's the style that we use on telescopes, is big black plastic ones with thick frames, but it lines. But it turns out what works the best is this Lonely Speck is the brand, and it's called Sharp Star 2, and it's lonelyspeck.com, and it's a laser etching on a plastic filter that you put in a photography filter holder, and that does the best job for DSLRs. So a couple of pictures here. This is what you'd actually see looking on your LCD. The stars become these little shapes like we described, and all of them are this little pattern that you can use to line up the focus. The Sharp Star Lonely Speck site has this compatibility where they talk about, you know, what size lens and whether it's a good fit or not. One thing I want to go back to, so, you know, this is what my methodology for this was to buy the filter for the biggest diameter lens I had. So the biggest diameter lens I had was a 77 millimeter filter thread. So I bought an 85 millimeter Sharp Star 2 on an 85 millimeter filter holder, and it has a step down ring to the 77. And you can leave that whole thing on the rig, and then there's just this one little screw here that you can undo that thumb screw, and then the filter holder comes off from the step down ring, and so that's a way to get it off of there without disturbing the focus, right? You don't want to do all this focus and then try to unscrew a filter, right? It's gonna move the lens. So that's how we do that. Oh, and there's a comment here about, you know, when you're trying to get in focus, you know, crank the ISO all the way up, make it as bright as possible so that you can see what's going on. You're not worried about noise at that point. Okay, so we talked about that. All right, the rule of 500. So the rule of 500 is going to tell us how long can I take an exposure before the stars are no longer round, they start to be lines, trails. So if you have a full frame camera, it's simple. You just take 500 and divide it by the focal length of your lens, and that's going to tell you the longest time exposure you can do without trails. If you've got a crop sensor, there's a little more math. If a Nikon, Canon, either 1.5 or 1.6, you have to multiply the focal length of the lens by that factor before you put it under the 500 to get your answer. Okay. Then there's for you analytical data types, there's a more involved rule called the MPF rule. So I don't know, you can it's too much data for me, but if you want to figure that out, you can do that too. Okay, and we're drifting off to the right here. How do we know we've got a good exposure? So we're going to use the histogram on the back of your camera, or if you're shooting tethered, in the image acquisition software. And be aware that the histogram is going to look very different than it does for terrestrial daytime photography, right? The histogram in daytime photography is going to be, pretty full all the way across and kind of waving around all over the place. At nighttime, it doesn't really matter and what you're taking a picture of. The histogram is going to look something like this. Okay, there's going to be this big spike on the left, and that's the sky. And the thing that you're trying to take pictures of is typically on this, I call it the north slope or whatever, the right-hand slope of this histogram, and then your brightest stars would be all the way over on the right. But if you're doing a nebula or something, it's probably going to be just barely brighter than the sky. So what we want to do is we want to put this spike in the histogram in somewhere in the first third of the histogram. We just want to create a little space over here on the left, and that's just to make sure that the sky is above the noise that's generated by the camera itself. And there's a lot more to that, but that's the simple view. Just create a little black space there. And the other thing you don't want to do, if you start to see a little piling up of stuff over here on the right, that means that your stars are clipping on the white end, on the bright end of the histogram, and you're going to lose star color, right? Because if they're all the way, if all the pixels in your camera that are being hit by those stars are fully white, then the thing is going to be white. RGB together all the way on the right will equal white, so you won't get the different colors of the stars at that point. So those are the two things to check for. Okay. So people can have long and very technically detailed and scientific discussions about ISO, and I kind of simplify it to just be use the ISO you need to get the shot, and if it's too noisy, then you needed to do something different so that you can use a lower ISO. But basically don't sweat it too much. But one of the things that I take advantage of high ISO for doing certain operations. So if I'm doing focusing, as I mentioned earlier, I want to turn the ISO all the way up. I want to go into my camera's menu and enable the high ISO in firmware so that I can go to 3264, 12,800 or above. That capability is in a lot of cameras and people don't always have it turned on. I want to use it when I'm framing the picture, deciding what's going to how I'm going to rotate the camera and all that. I want to use it when I'm deciding what my exposure should be. I'm going to use a high ISO short exposure to figure out what exposure I need at the ISO I'm actually going to shoot at. Okay, so if you can wrap your head around, ISO has stops just like f-stops have stops, right? So if you double the ISO number, that's a stop. So when I was using a DSLR, I used a Canon T3i Astro modified, which we can talk about, but its highest ISO is 12,800. So I would, if I want to do a nighttime deep space on the telescope, I might need like 8 minutes, but I don't want to spend 8 minutes figuring out that 7 minutes and 30 seconds wasn't long enough and I should really do 8, right? So what I do is I turn the ISO all the way up and maybe do a 60-second exposure, and that tells me that I needed the 8 minutes, right? So I'm going to shoot at 1600, but I'm going to do my exposure test at 12,800, and I know that I just need to multiply that by 8 to get the exposure length at the lower ISO, because it's 3 ISO stops, or 2 to the third away, basically, which is 8. So is that any questions on that? Okay. So then there's other, again, if you're using a DSLR, there's other things you want to turn off if you're doing nighttime photography, right? So we're going to shoot RAW, we're going to use manual focus, we're going to use manual mode. People often get hung up on this, my camera has long exposure noise reduction. Why do you want me to turn that off? It's there so that it can reduce the long exposure noise. Yes, that's exactly what it does, and it does it, you're going to take however, if you've got it on the telescope and you're going to take a 5-minute exposure, it's going to then close the shutter and take another 5-minute exposure, and it's going to subtract that second one from the first one, which is what you want. The problem is you just spent 10 minutes under a dark sky that you could have gotten 2 5-minute exposures, and you could do the dark subtraction later in software. So that's what we do. So you can put your camera in a camera bag with some desiccant in it, put it in the refrigerator to simulate the nighttime sky, and if you've got a Canon, you can read the sensor temperature to get it to exactly the same temperature, and then take your dark frames and you build up a library of dark frames at different temperatures that you're going to then match to your frames that you actually take. They're called light frames, even though it's dark. You take light frames and we'll subtract the thermal noise by subtracting with these dark frames, but we don't want the camera to do it for us. So turn that off. You need an intervalometer or use a laptop, and then there's a list here of some other camera settings, and there's stuff on the web. And don't let me forget, I actually summarized some of this stuff on a 1-page handout wherever my backpack is that I've got for you guys if you're interested. Okay, and then I kept talking about dew control, right? So one of my fun learning experiences was I was going to try and collect a meteor shower, and I put my camera on a tripod out on the hillside in the backyard, and I set up the laptop and I left it out there and went to bed. And when I got up in the morning, and the lens was just completely covered with dew, and I went ahead and processed that time lapse, and you see the Milky Way, or the stars rotating a little bit, and then it just sort of gets brown, and I never saw any meteors. So you need to plan for that sort of thing. And so I don't think in California you'd ever need 3 of these things, but these hand warmers are one way of warming up a lens. And I see now on Amazon they have everything's USB powered, right? They have USB powered lens warmers now on Amazon, but you don't want to put too much heat, because too much heat will literally change the shape of the lens and create air currents like you see on the desert coming off the asphalt, right? You don't want you want to just keep the glass on the front of the lens just ever so slightly above the air temperature, and that's all you need to do. But you do have to handle that. So there's this one site where they sell this little pouch with Velcro for holding the hand warmers. You could probably just use painter's tape or make something, sew it up yourself or whatever. He also used to sell these hats, which I really like, with lights, red and white lights on them, but he stopped selling those. The one I have now is got green and white lights on it. If you ever go out with visual astronomers, they're going to be very strict about only red lights, and cover all your laptops and everything screen, make it all dim. They wouldn't be happy with these blue meters down here, and so I had a flashlight, and it had a red button and a white button, and the red button had a rough texture to it, and the white button had a smooth texture. I figured I can manage that. They're different. They feel different at night, but I kept turning on the white light, and people like, Glenn, ah! So I got the hat, which is over there somewhere, and so the red's on the right, so it was easier to red on the right and white on the, and they've got like different white down, white out, red down, different switches. So that's a handy thing. People have headlamps on straps or whatever, different things that they use. Okay, so that is pretty much it. This is just a tabular form of all the different things that we've talked about, and I've included that on the handout. Also, some of you know that I have a bunch of stuff on YouTube, which is mostly about deep space, and deep space with a DSLR. And someday I'll get around to adding to, although there's plenty of people that do this with CCD cameras or whatnot on YouTube. But there's a lot of information there on the YouTube, and there's a list of the other websites that we have there. So it is probably plenty dark enough for us to see Polaris. So we'll switch gears and do that. Let me stop this recording.